So the last we discussed light topic. So for this light topic, we were discussing a refraction. Refraction means property of a wave to travel from one medium to another by changing the speed. So it can be a refraction through rectangular glass. So if you want to show a refraction through a rectangular glass, example, this is a rectangular glass. The light strike and it is making certain angle with the normal. So the light which is incident, the light which strike the surface, that's known as the incident light. Imaginary line, which is perpendicular or 90 degree to the surface, that is known as a normal. So when the light travel from air to glass, because the density of air is lower as compared to that of a glass, so it will refract, it will change its speed, slow down when it is making certain angle with the normal. So the angle of refraction will be smaller as compared to angle of incident. When we draw the normal at the other face, normal is always perpendicular to surface. So 90 degree to the surface is known as a normal. So when we draw the normal at the other face, what will happen? So normal is perpendicular to the surface or 90 degree to the surface. So when it travels from glass to air, it will bend away from the normal. Sorry, if we're moving from glass to air, bend away from the normal. And for rectangular glass, the incident and the emergent are always parallel to each other. This one is a refracted. But if it is traveling along the normal, like example, this is a rectangular glass slab, and the ray is passing along the normal, same as the direction of the normal. So what we will observe, it is if it is passing along the normal, then we don't observe the change in the direction. We only observe the change in the speed. Like the speed will change, but the direction will not change. Moving from air to glass, it slow down. Moving from glass to air, it will speed up, but the direction remain unchanged. This is a refraction through a rectangular glass. Then there's also a refraction through a semicircular glass. So if we have a semicircular glass, we also observe a refraction. Example, this is a semicircular glass. The ray which is incident. Now what happened when we draw the normal? Normal is always perpendicular or 90 degree to the surface. So if I draw to the normal will be same as the direction in which the ray enter, because you can see that is making 90 degree to the surface. So when the ray is passing along the normal, it only changes the speed. It does not change the direction. So in this case, moving from air to glass, what we will observe, we'll observe only the change in speed, but not the change in direction. So if a question is why, if this point is marked and this point is marked at A, and the question is why the ray does not change the direction at A. So what is the reason? The answer is because ray is passing along the normal or passing as same as the direction of the normal. That's why it does not change the direction at point A. But when it strike glass to air boundary and we draw the normal, so when we draw the normal, moving from glass to air, what we will observe, it will bend away from the normal. So this will be the trajectory or the path which the ray will follow through a semicircular glass. So if at any direction as it enter, it will pass straight. Why it will pass straight? Because every point position, the ray is passing along the normal at a circular edge. That's why it will pass straight. But once it strike the glass to air boundary, a refraction will occur and it will bend away from the normal. Is it clear? The refraction of the ray when it is passing, this is 1 and this one is 2, when it is passing through a semicircular glass. For this, we define a term, we call that as critical angle. What is the definition of a critical angle? If in an exam the question has defined critical angle. So the angle of incidence is known as critical angle if angle of refraction is 90 when light travel from denser to rarer medium. So the value of angle of incidence is known as a critical angle when the light travel from denser medium to rarer medium if angle of refraction is 90. So basically what happened, like this is a semicircular glass. And the light is incident. Because it is passing along the normal, so it will pass straight. Now it will strike a denser because this glass is a denser. Denser means higher density. And air is rarer. Rarer means low density. So the light strike a denser to rarer boundary. When we draw the normal imaginary line which is perpendicular to the surface, imaginary line which is perpendicular to the surface, that's known as normal. And what we observe light is refracted, means bend away from the normal. This value of angle was 30 degrees and angle of refraction example 68 degrees. So this angle of incidence is 30, but the angle of refraction is 68. So we don't call this angle of incidence as critical angle. Critical angle means when the angle of refraction is 90, means you have a surface, the ray of the light strike, it enter the denser medium, and when it strike a denser to rarer boundary, it travel along the surface. So when we draw the imaginary line, so the imaginary line, in reality it's not there, this is just imaginary line which is perpendicular to the surface, that's called normal. So what is this angle of refraction? The angle of refraction, angle between the normal and the refracted ray is 90. So if the angle of refraction is 90, the angle of incidence is known as critical angle. It can be any value. So the angle of incidence, the value of angle of incidence, example, if this was 42. So what is the critical angle in this example? The critical angle is 42. So but in this one, the first example, angle of incidence is 30 and angle of refraction is 68. So this angle of incidence is not this is angle of incidence, but we don't say it is critical angle. The term critical angle is used when the angle of refraction is 90, the angle of incidence is known as critical angle. Is it clear? The definition of a critical angle. The angle of the incidence is known as the critical angle if the angle of refraction is 90 degrees. If it is not 90, then we don't say it's a critical angle, we just simply say it's angle of incidence. But when angle of refraction is 90 degree, we specifically say the angle of incidence is known as a critical angle. So example, you have a semicircular glass. The light passes along the normal imaginary line which is perpendicular to the surface, that's also called, so first normal when it strike air to glass boundary, second normal when it strike glass to air boundary, and it is refracted. This was 35 and this one is 75. Another ray of a light with different angle of incidence, the ray of the light passes along the normal, along the surface perpendicular to the normal, and this angle was 40. So what is the critical angle here? What is the critical angle? So 40 is the critical angle because when angle of refraction is 90, if angle of refraction is 90, the angle of incidence is also known as the critical angle. So in this example, the critical angle is 40. How we can use a critical angle to find the refractive index? So as we know, the ray is passing, the angle of refraction is calculate, you can calculate, or you can also measure using a protractor. You can measure this. So both ways it can be done. Calculation can also be done and shows what will be the angle of refraction, as well as measurement can also, like protractor can also be used to measure this value. So a formula which relate critical angle. Critical angle is not necessary always 40, but normally it is in the range like 42, 41 for glasses which we use in the lab. Most of these glasses have the critical angle around 42. But it's not like a fixed number. It vary with different glasses. Even the critical angle vary. The formula which relate the critical angle and refractive index, this is the last time we discussed. It is moving from glass to air. So if a light is moving from glass to air, the formula for refractive index, as it is passing from glass to air, the formula for refractive index it's sin r over sin I. What is r? So r is 90. So we can say sin 90 divided by sine, and angle of incidence is also a critical angle. So critical angle we can denote by c, small c. Yeah, angle of incidence is 40. But for example, if you don't know the angle of incidence, for this is 40, but example, if you don't know what is the value, so the variable which we use a letter c to represent a critical angle. And when you check the calculator, you will always find that sin 90 is equals to 1. So sin 90 is 1, so this whole factor will be 1. So the formula which relate critical angle and refractive index, n is equals to 1 over sin c. So if I know the critical angle, I can find refractive index by simply using a formula n equal 1 over sin c. From where I got this one? When you use a trigonometry, a sin 90 using a calculator, you will find the value of the sin 90 is equals to 1. So this is also a formula. In exam, if critical angle is given, you can find refractive index, or if refractive index is given, you can find the critical angle. Is it clear? In the first one, the first example, this angle of incidence is there, but this angle of incidence is not equal to critical angle. In the first example. In the second example, the angle of incidence is equal to the critical angle. So what you can do, like example, if I say we have a glass, the formula for critical angle, because the light is moving from glass to air, when it travels from denser to rarer, the formula is refractive index is sin r over sin I. What is r? Whenever the critical angle is there, the angle of refraction is 90. So in place of r, I can put 90, and sin 90 is equals to 1. So we can say n is equals to 1 over sin c. So example, if you have a surface is given, and you have glass, The refractive index of the glass is given 1.5. And you have to sketch a path for this light ray. Like it is striking a glass to air boundary. The refractive index is 1.5. Refractive index means ability of the medium to bend light, the tendency or capability of a medium to bend light. Like 1.5 refractive index means compared to air, this has 1.5 times capability to bend the light. So example, the light incident and the question is complete the path, find the refractive index, find the critical angle and complete the path. And this angle was say 30. Before complete, we know the angle of incidence is 30, but first what we will do to complete a path, we should know what is the critical angle of this glass. So when we find the critical angle, that's the first thing, find a critical angle. So how to find a critical angle? The formula which relate the refractive index and the critical angle. So n is equals to 1 over sine c. That's a formula which relate the critical angle and the refractive index. We don't know whether this 30 can be critical, it may not be critical. We don't, the angle of incidence is 30, but we don't know 30 is a critical angle or not. So we are finding it. So we will consider this as unknown. Refractive index will be there 1.5. Refractive index is 1.5 equal 1 over sine c. If I need sine c, so cross multiply sine c is equals to 1 divided by 1.5. 1 divided by 1.5, what's the answer? 1 divided by 1.5. 0.66. So 0.66, but I need angle, I need C. So take a sine inverse. 0.667. Sine inverse. As I need C. .666. What's the answer? So it is coming out 41.8. So what it shows? It shows this is the critical angle is 41.8. Now we have to complete the path. So this is angle of incidence. You can see this angle of incidence is less than critical. So if it is less than critical, if angle of incidence is less than critical angle, then angle of refraction will be less than 90. It will be any value, but it will not be equal to 90. So when we complete the path, so how we complete the path? We will just complete a path to show a simple refraction. But if another ray of the light is there, another ray of the light, and you have the angle of incidence exactly equal to 41.8. So if angle of incidence, this was 41.8. So you can see the angle of incidence is equal to critical angle. So if angle of incidence is equal to critical angle, then what we will observe? We'll observe the angle of refraction will be 90. So it will pass along the surface and the angle of refraction will be 90 degrees. So these are the possibilities. Then there is also another possibility. If angle is more than the critical angle, then what will happen? The angle of incidence. So the first possibility, the angle of incidence might be less than the critical, then a simple refraction will occur. The second possibility, the angle of incidence might be equal to critical. So if it is equal to critical, it will travel along the surface and the angle of refraction will be exactly 90 degrees. But if it is more than the critical angle, like the third possibility, if you have a surface and the light strike, as this is a continuation of the previous example in which we worked out the critical angle. The critical angle was 41.8. And now the angle of incidence is 43. So this 43, the angle of incidence is more than critical angle. So if the angle of incidence is more than the critical angle, then what we will observe, there will be no refraction. All the light reflected back. This is known as total internal reflection. So if the angle of incidence is more than the critical, as you can see, the critical angle is 41.8, but the angle of incidence is 43. So what we observe, we don't observe a refraction, we'll observe a total internal reflection, means all of the light reflected back in a same medium, and in that case the angle of incidence and angle of reflection will be same. This phenomena, when the light travel back in the same medium striking a surface, is known as total internal reflection. So three possibilities are there depending on: number one, if angle of incidence is less than the critical angle for the medium, a simple refraction occur. If angle of incidence is equals to the critical, then refraction will occur. This is also a refraction, but refracted at an angle of 90. But if it is more than critical, then what we observe? We'll observe that total internal reflection occur, all of the light reflected back in a same medium. Is it clear, this example of total internal reflection? Another example, if ray of a light is passing through a semicircular exactly perpendicular, it will not change the direction, no change in direction at all. If it is making certain angle with a normal, then there will be a change in direction. Example, you have a semicircular glass And the refractive index of this glass (1.6), and there's a ray which is passing. First, when it moved from air to glass, because it is exactly perpendicular 90° to the surface, so passing along the normal, so it will pass straight without changing a direction. Now the question is, complete a ray diagram. Now we have to complete this ray diagram. So before completing a ray diagram, we should know the critical angle. And this angle was given, say, 42. And you have to complete a ray diagram. So before completing a ray diagram, we should know the critical angle. We know angle of incidence, but we don't know critical angle. So first we'll find the critical angle, the formula to which relate the critical angle and refractive index. Refractive index is equals to 1 over sine C, or sine C is equals to 1 over n. We need C. So sine C is equals to 1 divided by 1.6. What's the answer? 1 divided by 1.6. 0.625. Then for this 0.625, take the sine inverse. That is sine C. So C is equals to sine inverse 0.625. That's 38.7. So we worked out the critical angle is 38.7. So if critical angle is 38.7 and the angle of incidence is 42. So when we compare, in this example, angle of incidence is more than the critical. So if angle of incidence is more than the critical, what we will observe? The critical angle is 38.7, but the angle of incidence is more than 38.7. So which phenomena we'll observe? A, B, or C? So we'll observe total internal reflection. The complete reflection, it's having a specific term, we call that as a total internal reflection. So in this total internal reflection, you will just simply sketch the path. So this will also be 42. And what we observe when angle of incidence is less than or equal to critical angle, we observe partial refraction and reflection. But when angle is is more than the critical angle no refraction, all the light reflect in the denser medium. This is what we observe, the partial refraction and reflection if the angle of incidence what's the meaning? Like example, if I say you have a glass, I'm just drawing a glass surface, three different examples I will show. Say the critical angle is 42. Reason why I'm taking 42, because even in exam, most of the example you will find the critical angle is 42. But that's not a universal that everything is having a critical angle 42. A critical angle may vary, but most of the example you will find in exam, the critical angle is approximately 42. So example, you have critical angle equal to 42. Light strike, say this is a denser medium, a glass, air, air and glass, air and glass. The light strike, the denser to rarer boundary, this angle was 30. So what will be the path followed by the ray? A, the B or C? Which path it will follow? A, B or C? Majority. So it will be less than, it will follow path A. But what we observe, it will follow path A, that's right. But we also observe a partial refraction, a partial reflection, means very small amount of light. Most of the light is refracted. Mostly what happen is a refraction. But this very small amount of the light is small proportion only, not too much, but a small proportion is reflected. But this is called partial reflection and refraction. If the angle of incidence, as we know, the critical angle is 42. So if the angle of incidence is 42, so if the angle of incidence is equals to 42 degrees, so what we observe a refraction occur exactly at an angle of 90. And again, it's very small. Mostly it is refracted and very small amount of light, not too much, but very small amount is reflected. This is called partial reflection and refraction. But when it is equal or more than the critical angle, if the angle of incidence is greater than critical angle, then what we observe instead of light reflected, refracted, all of the light is reflected back in the same medium and there is no refraction occur. This is called total internal reflection. So basically here in the first example, this is a partial refraction and reflection. Here also partial refraction and reflection. But this side, there is no refraction there is all reflection, which is also known as total internal reflection. So if angle of incidence, if the value of the angle of incidence is smaller or less than the critical angle, partial reflection occur. Equal to critical angle, partial reflection and refraction. If it is more than critical, then there is no refraction. All of the light is reflected back in a same dense medium. Some questions now related to this total internal reflection and refraction. The diagram shows a ray of a light in a glass. The ray reaches a boundary with air. One weak ray of a light is missing in the diagram. Which ray is missing in the diagram? One weak ray is missing in the diagram. Yeah, D is the right answer, because what happened, if, as you can see, the angle of refraction is 90. If angle of refraction is 90, angle of incidence is known as critical. So critical angle is, if we read the statement, at the D is the right answer, but at the boundary the speed of a light become less. So that's wrong. Speed of the light become more, because light travel faster in air as compared to that in a glass. So A cannot be a right answer. Critical angle is 50. No, critical angle is not 50, it is 40, because angle of refraction is 90 and angle of incidence is 40. So this statement is also not true. The diagram shows a example of a diffraction. Diffraction means the spreading of the wave when it passes through a gap. So it's not passing through a gap, it is traveling from one medium to another. So it is a refraction, not example of diffraction. So the ray which is missing is a reflected one, because if the angle of incidence, even it's a critical angle, there is a partial reflection and refraction. Question 15, what could be the answer? The diagram shows a ray of a light inside a glass rod. The critical angle is 42. Which row shows what happened to a light when it reaches the surface? Any light reflected, any light refracted? Yes, again, D is the right answer, because the angle of incidence, you can see the angle of incidence is less than the critical. And if we have angle of incidence which is smaller than the critical, a partial reflection and refraction will occur. So some of the light will refract, but it will not be exactly 90, because it's not equal to angle of the critical angle and angle of incidence are not equal. So partial reflection and refraction occur. Question 17. The diagram shows a ray of a light passing through a semicircular glass block into air. Which row gives the correct name of angle P and state how P compare with critical angle? Yeah, that's right. B is the answer, because the angle of refraction is not 90. If angle of refraction was 90, then it will be equal to critical angle. If it is all reflected, there is no refraction total, then it will be more than. But because it's a simple refraction, so P is angle of incidence and angle of refraction is not 90. So it means it is not equal to critical angle. It is smaller than the critical angle. Question 21. The diagram shows a ray of a light traveling from X. The angle P is less than the critical angle. In which direction does the ray continue? Yes, B is the right answer because this angle is less than the critical. If it is less than critical, a simple refraction. Equal to critical angle, A will be there. A scientist tries to direct a ray of a light in a glass block so that no light escape from the top of the block. However, some of the light does escape. The scientist changes the X and stop a light escaping from the top. Which row in the table describe the change to angle X and the name of this effect? Like what he should do to this angle X? Because this X is smaller, less than the critical, that's why it was not happening. Like, so it should be more than the critical. So if to be more than critical, we should increase this angle. Then application of this total interreflection, also known as optical fiber or fiber optics. Basically, what is optical fiber or fiber optics? It is made up of transparent material, a cylindrical, very thin wires, tubes made up of transparent material. When we say transparent, it means the light can pass through it. But what happened? How we use this optical fiber or fiber optic? So when we incident light from one end, this optical fiber, the core, this is a core. This optical fiber core is having high density compared to that of air. So this is a denser medium, air is a rarer medium. So when it strikes the surface, this angle of incidence is more than the critical angle. So at this point, the first point A, if I say at point A, the angle of incidence is more than the critical angle. So if angle of incidence is more than the critical angle, what will happen? The light will reflect. Instead of refraction, a reflection occur. Then when it strike another boundary, we draw the normal. Again, the angle of incidence at point B, the new angle of incidence is more than the critical. So at point B, angle of incidence is more than the critical angle. What will happen? Light will again reflect, and the light will reach at other point. So what we can use, we can use optical fiber to transmit the signal in the form of light, because it is 99%, 99.9% efficient. It's not absorbing, it's a transparent material, so it does not absorb energy and absorb light. And what happened, because the angle of incidence is more than critical angle, light is only incident at a point where the angle of incidence is more than the critical angle. So all of the light we can receive at other end. So we can use this optical fiber or fiber optic to transfer information or data in the form of light. And what are applications of these optical fiber? Optical fibers are used for communication, like internet communication, mobile, as well as in medical field, endoscopy. How we use optical fiber or fiber optic for communication? Example, you're using your computer, a CPU. So this is a screen, the monitor, central processing unit, and your keyboard. So how we can use this optical fiber for communication? Example, you're using, say, STC for internet service provider. So this is their station, like the main server. So you're connected, if you are using a internet, you're using a connection of fiber optic or optical fiber. So you're connected by fiber optic or optical fiber to the internet service provider, ISP. Now, when you press, like example, you're searching a word, say physics. So when you try to search a word physics, a computer generates an electrical signal. When you press a key on the keyboard, actually it is generating a current. So when you type any words, example, you type a physics. So what happened? This word first converted into electrical signal. The computer language is electrical signals only. So it first convert into electrical signal. And that electrical signal, because in your computer, that electrical signal, when electricity is there, you can convert that into a form of light. And when it is converted in the form of light, so what happened? That light will undergo total internal reflection, because the angle of incidence is more than the critical angle. So this light will undergo total internal reflection, and your internet service provider will return that information which you search in the form of light as well. And as it receives, your CPU, central processing unit, receive that. Again, what it do, it convert this light into electrical signal, and that electrical signal will generate the search result. Why it is more effective? Because, and with a blink of an eye, you are able to see your search result. Reason for that, the speed of the light. The light is super fast, like 300 million meters light can travel in 1 second. So just the moment you press, you search any keyword, it will convert into a form of light and undergo a total internal reflection and return to you in a short time interval. So this is how a communication is done. And what we use for this communication, there are different modes of communication, Like sky communication is there using microwaves, but we also use these light waves and optical fiber. The advantage of using these optical fiber or fiber optic, because of their efficiency, about 99.9% efficient. Is it clear how a communication is done by using optical fiber? In exam, they don't ask how, like explain how information transfer from one place to another. Only you should be able to complete the path of fiber optic or optical fiber. So normally they give you fiber optic and they say complete the path, but don't complete the path and show multiple reflection. Don't do like this. This is practically also not correct. Like if you show a lot of reflection, so you will lose the mark. Try to show minimum reflections, greater angles, only minimum 1 or 2 reflection, and the light will reach at the other end. So we use fiber optic or optical fiber for communication. Is it clear? Then there's also another use of fiber optic or optical fiber for in endoscopy, medical field. We use endoscopy. Like example, if a doctor want to examine like esophagus or a stomach, so how they can examine? So they use optical fiber or fiber optic. So what will happen? And instead of using one piece, they use thin optical fibers or fiber optic, but bundle of optical fiber bundle. It will give a more detailed image and it will be flexible instead of using one piece. So example, this is a bundle of optical fiber. A doctor want to examine, say, a stomach in a. So how they use this optical fiber or fiber optic to examine? Say this one is a wall of the stomach, inner wall. So the light will undergo total interreflection. So the incident, the light will strike, because inside the stomach you don't have any light source. So it should be illuminated to observe or see. So from one fiber, the light incident. So when this light incident, this light will undergo total interreflection and strike the inner wall and return back through the other fiber, and you're able to see or examine, the doctors are able to examine the internal organ. So light undergo total interreflection and bounce off from the inner wall and return back, so we can examine. I will show a question related to this endoscopy. Look, here is a question. A ray of a light passes through a length of a curved optical fiber. Draw a diagram to show the fiber and the path of the ray. So how you represent optical fiber or fiber? So this is optical fiber, and show the path. So when you show the path, minimum reflection, total reflection will be there, but minimum, do not show multiple reflection. Then next they are asking, describe one use of optical fibers in medicine. You may draw a diagram. So one use of optical fiber. So what we can write, you can mention endoscopy and then explain endoscopy. So The points which you will use. So we use endoscopy. Insert the fiber, bundle of optical fiber, because the question is how it is used. The light will undergo total internal reflection. And internal organ can be examined. You don't have to be precise with the angles here. This is just a sketch. So you don't have to be precise. Like if this angle is 30, you will measure. It will not be precisely. So what happened in endoscopy, if you want to examine like the stomach, say this is the inner wall of the stomach. So doctors, they use endoscopy, they use bundle of optical fiber, and the light is incident. The light will undergo total internal reflection, bounce off from the inner wall and return back through the other fiber. So using a bundle, so it will make it flexible, bend easily instead of using a big or a large piece. Is it clear? The endoscopy. So in exam, you will you may, if they say you may draw a diagram, it's better you draw a diagram. So if you lose, like if you miss any point in explanation, so you will get marked from the diagram. So prism is also a refracting surface which is having, it can be a 90-degree prism, perpendicular prism, different type of prisms are there. All prism is also a refracting surface. So when the light is passing, if it is passing along the normal, so if it is passing along the normal, it will pass straight. Example, the critical angle of a prism is 42. So if you want to work out the angles, measurements are not given, like what will be the angle of incidence. So you can also work out because for triangle, like if this was 90, this is 45, and this one is also 45. The total sum is 180. So what will be this angle? So this will be 90. What is this angle? 45. And this angle will also be 45. So what is the angle of incidence in this example? When it is traveling from glass to air, what is the angle of incidence? So angle of incidence is 45. Why 45? In this figure, look, why it is 45. You can only these angles are given, and the question is you have to complete a path. But to complete a path, you have to check whether the angle of incidence is less than critical angle, or angle of incidence is equal to critical angle, or angle of incidence is more than the critical angle. So you should check the angle of incidence first. Critical angle is 42. So this is a 45-degree prism. So if this angle is 45, this one will be 90. So remaining this will be 45, because the total sum of the triangle angle is equal to 180. And what about this one? The normal is making 90 degree. If this angle is 45, so remaining 45 will be there. So angle of incidence is 45. So if angle of incidence is 45, so which scenario, if angle of it shows that angle of incidence is more than critical. So if angle of incidence is more than critical angle, then what we observe total internal reflection. So this light will reflect back, and because it is passing along the normal from the surface, so it will pass straight. Is it clear? The path of this light, because in this example the angle of incidence is more than the critical angle, that's why it follow a trajectory or a path which is shown. If you have another prism, say the critical angle is 42, but the type of prism is different. Say this was 90, 30, 60. Because initially the light is passing along the normal, so it will pass straight. You have to complete the path of this ray. Complete the path of this ray if the critical angle is 42. So if what is the angle of incidence at this point? What will be the angle of incidence? The angle of incidence will be 60. Why? Because this will be 90, this 60, so this remaining is 30. If this one is 30, then the angle between the normal and the incidence will be 60. So again, you can see the angle of incidence is more than the critical. If it's more than the critical, it means the total internal reflection. So total internal reflection, the ray, the angle of reflection will also be 60. And now it is making certain angle. So if it is making certain angle, we'll draw the normal. Always draw the normal. When you show a refraction, a normal is always perpendicular to surface. So this one is a surface and perpendicular to the surface. That's normal. So moving from glass to air, what we will observe, again we have to check the angles. So look, this angle will be 60 that we worked out. So this will be 90. It depends on how many times you have to show. uh, in the question, it depends. Sometimes they say only complete the path to show the first refraction or total internal reflection. So it depends on this angle of incidence. If angle of incidence is more than critical angle, then there will be total interreflection. If angle of incidence is less than the critical angle, then there is no total internal reflection. As you can see in this question, a ray of a light in a glass is incident on the boundary with air. State what happened to ray when the angle of incidence is less than the critical angle. If it is less than critical angle, what we'll observe? Angle of incidence is smaller than the critical angle. So a refraction with an angle less than 90, that's right. And the second part, yeah, that's also right. Majority of the light is refracted and partial reflection will be there. If it is greater than critical angle, then we'll observe the total internal reflection. Now, in the next question, it's a similar question which I was discussing, that you have to complete a path. So figure 6.1 shows a ray of a light incident on a glass at A. The critical angle is 41 and you have to complete a path. So first thing, what you have to do, you have to draw a normal. So when I draw a normal, what will be the angle of incidence here at B? The angle of incidence will be 60 degrees. So if angle of incidence is 60, so at B, because the angle of incidence is more than the critical angle, then what we'll observe? Total internal reflection. Total internal reflection. So this one, it's better you draw with measurement. It's not to scale, but the thing is, to avoid any error, you can draw. So when we draw the reflected ray, this will be the reflected ray. So this angle will be 60. Now we have to complete the path. Again, I will draw a normal. Now the normal at this surface, what will be the angle of incident now? What will be this angle of incidence? This will be equal to 30, that's right. So if angle of incidence is 30, if I say this is point C, so at C, because the angle of incidence is less than the critical angle, so a simple refraction occur, it will bend away from the normal. So when we represent a simple refraction, we will draw. It will bend away from the normal, and this is how a refraction will occur. Is it clear, this example? A refraction of a light. So in the question, red light traveling in air strike the surface a semicircular glass at P. Figure 8.1 shows a ray of a light, a red light is passing. The light travel in a straight line from O to P, O to Q, sorry, means it does not change the direction, it goes straight. The question is, what is the reason why it does not change the direction at, why the light does not change the direction as it enter at P? So what's the reason why there is no change in direction at P? So it is traveling along the normal or at a 90-degree. That's why it does not change the direction. Yeah, or it is passing along the normal. In the next part, they ask the direction, reason why I skip part B. Part B is what we discussed last week, like calculating the angle. So I'm only discussing the total inter-reflection and critical angle questions. The direction of the light strike the curved surface of glass is changed. The angle of a ray, the angle between the ray and the normal is gradually increased from 30 to 90. Describe what happened to a light that strike a block at these increasing angles. So what we did, we changed this angle. Like first it is 30, then example we made 35, then we made 40, then 45, then 50, and so on. So what we will observe if we change this angle, initially because this angle is less than the critical angle, but if we increase the angle, what we'll observe, it will bend towards the surface, a refraction, and there will be a certain angle at which the total internal reflection will occur. So you will explain this in your own words. Is it clear? Any question related to the class today? Total internal reflection, critical angle, optical fiber or fiber optics, and its applications you have to go through. Tomorrow we'll discuss topic lengths, which is also a very important topic related to the exam point of view. Any question related to the class? Okay, so I'll end the session and start the chemistry class after 30 minutes.